Welcome back to Intermediate Macroeconomics with me, Professor Liam Malloy. Today we are going to actually do something a little bit different. We're going to look at how to get macroeconomic data from FRED. And FRED is every macroeconomist's best friend. It is the Federal Reserve Economic Database that is run by the St. Louis Federal Reserve Bank. If you haven't been on there, I highly suggest it. It takes economic data from lots of different sources, both within the United States but also outside the United States, and puts them together in a very easy to use format. And you can make the graphs on FRED. You can download the graphs, which is download the data and make the graphs in Excel or Google Sheets, which is what we're going to do today. So if you haven't, been there, this is the address. It's just fred.stlouisfed.org. And so let's go there. All right, so here is the website. There's lots of ways to get the data. I usually just use the search box up on the top right. There is also an add-in for Excel. You can sort of search straight from Excel. And there's lots of data sources, right? So it says 788,000 U.S. and international time series from 103 sources. So time series, that means data over time, right? And that's usually what we're using in macroeconomics, both because we're concerned about, recessions and expansions, but also long-run growth. And so today what I'm going to do is we're going to download some data related to Okun's law and the Phillips curve. And then in the next videos, we will see how to graph that data and sort of check on the relationship between unemployment, real GDP growth, and the inflation rate in Excel and Google Sheets. So the first thing we need is the unemployment rate. So I usually just put this right there, but I usually just put it in, unemployment, and boom, the unemployment rate is there. So it takes us right to it, nice graph. Now remember, this is a time series graph, so the gray bars here are recessions. You can see the unemployment rate goes up in recessions and down in expansions, as we would expect. A couple things to note. So we have to think, when we're thinking about time series data, we have to think about a few things. One is, what's its period? The unemployment rate comes from the household survey that the current population and the Bureau of Labor Statistics do, and it's monthly. Real GDP, on the other hand, comes from the Bureau of Economic Analysis, and it is quarterly. So we actually are going to want at least quarterly unemployment data, but actually the data for Okun's law and the Phillips curve works best with annual data. So that's what we're going to have. So we're going to go here to edit graph, and instead of monthly, what we're going to do is annual. And as you'll see, there's lots of ways we could choose the sum. That wouldn't make sense for most data. Or we could do the end of period. That might make sense depending on what you're looking at. But we're going to use the average. That probably makes the most sense. So you can see now the data is much less bumpy, right? Because it's annual data rather than quarterly data, or rather than monthly data. And we're going here from 1948 to 2020. Okay, so this is our unemployment. Now, for Okun's law, we know that the relationship is between real GDP growth and the unemployment rate. So first, we are going to look for real GDP. So we have to decide, what do we want, right? There's lots of options for real GDP. So here we have quarterly real GDP, seasonally adjusted. So if you haven't come across seasonal adjustment, basically there are patterns in the data that are related to the month or the quarter, and seasonal adjustments tries to smooth out those patterns. And so you can see we have a seasonal adjusted option and a non-seasonal adjusted option. It really depends on what you are interested in, whether you want to get the seasonally adjusted or non-seasonally adjusted. For us, actually, it's not going to matter at all, because we're using annual data. And of course, there's no seasonal adjustments over the year. We do want total gross domestic product rather than per capita for Okun's law. So we just want this top one. So we're going to choose that, add data series. And instead of quarterly, we want annual. We'll keep the average. Now, what happened? Well, this is real GDP. Okun's law is really about real GDP growth, right? So instead of billions of change 2012 dollars, what we want is the percent change. Now, we could just do percent change or percent change from a year ago. Since we have annual data, they should give us the same thing. I'll just do percent change from a year ago. Okay, so now we have the unemployment rate in blue and real GDP growth in red. Okay, now for Phillips curve, we need inflation. And again, there are lots of options for inflation, right? We could use the real GDP deflator. We could use lots of different measurements from the consumer price index. We will use the standard CPI. So CPI, consumer price index, this is the most usual one. Consumer price index for all urban consumers, all items in U.S. city average. So city average, that gives us the urban. We could do total all items for the United States. We could pull out food and energy, which might be interesting. But we're just going to stick with this top one for now. And this is actually going to already give us the percent change from a year ago, simply because that's what we asked for in the last data set for real GDP growth. So we do need to make sure we change it to annual so that we get the same period for all three. And okay, so these are the three data sources that we're going to work with for our Okun's law and Phillips curve graphs. Now, we can do the graphs in Fred, but I find it's a bit easier to do the graphs in Excel. So we're going to download the data, save it in Excel. We could save it as a CSV file. It doesn't really matter. Let's see, we'll save it into this here. We'll call it this. We'll call it 2 since I already did this once. And then we'll save. And there you go. That's all you have to do to get the data from Fred into Excel.